Hello everyone and welcome back. In our last video, we showed you the pie chart visualization. Today, we're diving under the hood to explain the domain service, the critical business logic that powers and feeds data to that chart. While in our previous video, we created a pie chart and showed how to do the data binding to our dashboard. But we mentioned that for this binding to work, we needed to write the underlying business logic. You might be wondering why we can't just bind the chart directly to a single data source. The reason is that a pie chart requires very specific aggregated data, like the total days for each leave type. Our raw data, however, is a list of individual leave applications. To transform this raw list into the summarized format the chart needs, we have to write a custom domain service. This service acts as a data processor, and in this video, we are going to show exactly how we have written that business logic or domain service for this particular chart. To understand this in a better way, we will start with the foundational elements, the schemas, or what we call data models, required for this domain service. Navigate to the Data Modeler section, and in the bounded context, you can see we have three key schemas: employee, leave apply, and leave type. These are the three schemas involved in the creation of this domain service. The leave apply schema is particularly important because it contains all the leave details for every employee. If you look at it, you'll see fields like employee, leave type, from date, to date, and number of days. This is our source of truth for all leave transactions. Our goal for the pie chart is to show the number of leaves taken by an employee broken down by the leave type, which makes this schema central to our logic. So, now that we have a solid understanding of the data sources we're going to be working with, which is the actual raw materials for our logic, now the next thing we need to do is to actually start building the service that will bring it all together. This is really where the magic happens, where we move from just looking at the data to actually building the instructions that will process it. So, with that foundation in place, let's go ahead and transition from the data modeler over to the domain service section itself, where we can finally start constructing that business logic piece by piece. Now, let's move into the domain service to see how we've created the logic. We go to Domain Service, click Add New, select API, provide a name and description, and Continue. For efficiency, we have already created the logic, so we will navigate to the API we created called Leave Type-Based Pie Chart. Inside, you can see we have used Devum's extensive library of functions. We can simply drag and drop these functions to build the entire business logic. For instance, you can search for a function in the search bar and drag it into the workspace. Here, we have already assembled the logic, and I will now explain each part step by step. To reiterate our primary goal, we need the domain service to specifically prepare data for a pie chart that visualizes an employee's total leaves broken down by leave type, such as annual, sick, or casual leaves. The first step is to get that particular employee's leave details. We start with a DB filter function. In this filter, we are querying the leave apply schema. With DB filter, we are filtering the particular employee's leave details. We set the filter condition to where the employee field is equal to method.input.params.employeeID. Here, the method.input.params object serves as the critical entry point, capturing the essential input passed directly from the dashboard page. You may recall that in our previous video, we established the binding of the employee ID from a front-end UI container to this specific data source. That crucial ID value arrives here and is immediately leveraged to filter our large leave apply schema. The successful output of this detailed filtering operation, which we have conveniently stored as variable 1, is a clean, manageable data table holding only the comprehensive leave records for that single, targeted employee. In our last pie chart video, we binded the ID from the container to our data source. Basically, the ID will come to method input params.employee_ID. And that ID is getting filtered in leave apply schema and records are got stored in variable 1. Next, we're going to use a function called dbfindAll. This function is designed to retrieve all the records from a particular schema and store them into a variable. In this case, we'll be saving the results into variable 2. Now, once we select the schema name from the drop-down list, the dbfindAll function automatically fetches all the data and stores it inside variable 2 as data table format. And in variable 1 also response will save as data table format. The third function we'll be using is the map function. You can think of the map function as similar to a for loop in programming. Just like a for loop, the map function executes a specific set of actions multiple times, once for each item in the given input or list. Here, variable 2 is provided as the input to the map function. Remember, variable 2 is the output we received from the dbfindAll function, which fetched all the records from the leave type schema. The map function will now go through each record inside variable 2, and for every record, it will execute the subfunction or logic defined within the map. To represent each record from variable 2, we can assign a temporary name or label. In this example, we've given the name each to represent every individual record inside variable 2. Now, variable 1 holds only the records for the selected employee. Inside the map function, we use a filter function to narrow these records further based on each leave type. The filter function doesn't fetch data from the database. It works on the data already stored in memory. We give variable 1 as its input and set the condition where the leave type equals each .id. Here, each ID refers to the current leave type being processed. The filtered records for that leave type are stored in variable 4. From this filtered list, we need to calculate the total number of leave days. To do this, we use the sum function, which adds up the number of days field from all the records stored in variable 4. Variable 5 stores the total days for that leave type. Now, the back-end action response builder function is used to generate the final response. We've already created the response fields, which include leave type name, leave type color, and leave type count. The first field is leave type name. Inside the map function, we've named each record as each. So each name assigns the leave type name for each record in the response. The leave type color field assigns different colors to each leave type, as specified when creating records in the leave type schema. Like each .name, we can use each .color to set this field in the back-end response. The final field in the response is leave type count. We first filter the leave applications of the employee by each leave type ID, then use the sum function to add up all the number of days, storing the result in variable 5. This variable 5 is then used to set the leave type count field in the back-end response. Next, we use the return type function to return the constructed response as a data item. For each iteration, the new record is added to variable 3, so that by the end, variable 3 becomes a complete data table. Finally, we use another return type function to return variable 3 as the response to the page for the pie chart. This is how we constructed the entire business logic. Once the logic is built and saved, we go back to our dashboard. We select the pie chart, go to its properties for data binding, and bind it directly to this domain service we just created. This is how the pie chart gets the perfectly formatted data it needs to populate correctly in the UI. So, to summarize the entire procedure, our first video showed you how to create the chart and bind it, and in this particular video we have shown you how we created the domain service that makes it all possible. Thank you for watching.